Now let's take a look at several examples of dividing exponential expressions. Let's take a look at the first one. That's example 8, x to the 8th over x cubed. Since the power is greater in the numerator than in the denominator, when I subtract, my answer will go in the numerator, so that's x to the 8 minus 3. If you wish, you can say over 1, which is x to the 5th. Again, of course, in our final answer, we don't want to write over 1. It's not simplified. Looking at the next example, x to the 5th over x to the 11th. Well, now the power is greater on the bottom, so our answer is going to be x to the 11 minus 5, right? We still subtract, but it's going to be on the bottom and not the top because the power on the bottom is greater. And on the top, again, is a 1, and that leaves us with 1 over x to the 6th. Let's look at the next example. 12x to the 4th, y to the 6th, over 10x to the 7th, y squared. I will first do this the really, really long way, and then I will show you how you should think about it in a more simplified manner. So what you have, if you look at exponents as repeated multiplication, on the top is 12 times x to the 4th. So 4 x's times y to the 6th, so 6 y's. On the bottom, you have 10 x to the 7th, so 7 x's that we're multiplying. Y to the 2nd, that's 2 y's. And what you basically have as your answer, well, of course, 10 and 12 can both be divided by 2 to reduce to 6 over 5, but notice you can simplify 4 of the x's, leaving you with 3 x's on the bottom. And you can simplify 2 of the y's, leaving you with 4 y's up top. And so your answer is 4y to the 6, y to the 4th over 5x cubed. That's the really, really long way of thinking about it. You certainly shouldn't do that every time. The way you should think about this is, notice that what we basically did is we simplified the x's separately, the y's separately, the numbers separately. And that's how we should do it. 12 and 10 are both divisible by 2. That becomes 6 over, 5. X to the 4th over x to the 7. 7 is bigger than 4. So x's will end up being on the bottom, and 7 minus 4 is going to be 3. And the y's, well, 6 is bigger than 2. The y's will end up on the top. And that's how we get 6y to the 4th over 5x to the 3rd. So even with something this complicated, it's really as simple as subtraction. Let's take a look at one more example. 15x to the 6th minus 9x to the 4th plus 12x squared over 3x squared. What we have on the top is not just one term, right? We have 3 separate terms. And this should tell you that the appropriate thing to do is to use the distributive property. You can distribute the division. So 15x to the 6th over 3x squared minus 9x to the 4th over 3x squared plus 12x squared over 3x squared, just like we did in earlier sections. And now we will just simplify each expression. 15 divided by 3 is 5. And x to the 6th over x squared. Remember, we subtract the exponents. 6 minus 2 is 4, so that's x to the 4th minus, well, 9 divided by 3 is 3. And when we subtract the exponents, right, that's what we do when we divide. 4 minus 2 is 2, so that's x to the second, plus 12 divided by 3 is 4, and x squared and x squared cancel each other out, so there are no x's, and our final answer is 5x to the fourth minus 3x to the second. And so hopefully these examples gave you a better idea of how the division rule is applied. When you divide exponential expressions, you subtract the exponents. And just be careful to note whether the bigger exponent is on the top or on the bottom, because that determines where your variable is going to end up.